Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, people. Good evening, one and all. So, we have started with postulates of quantum mechanics, and early in the morning, we had a lot of fun playing with the expectation values. Basically, every values. They are also better than expectation values. Then we learned how to calculate probability also in different cases. We learned the generalized formula. We learned what happens if the coefficients are complex. We learned what happens if the wave function is normalized for orthonormal basis and everything. So now, let us continue from the same. What I will do is I will immediately take a problem related to what we learned already. Okay. So one combined problem of it all. Hang on. Actually, wait, no, before I take this problem, I need to teach you a small concept also. Okay. But before that concept, okay. So let's do one thing. Please just give heading probability density. Probability. So let me just check this. Hang on. I need to change the setting of the pen a bit. Okay. 10 seconds. Done. Let me check again now. No. Better. Okay, something which I know, sir. I forgot to take the class in the morning. So I think video access is available too, luckily. So you have to go through the video. Okay. Next. So please give heading probability density. Okay. People density already know it's basically something upon length or something upon area or something upon volume. Basically, it depends whether we're talking about 1D, 2D, or 3D. Charge density are also linear density, surface charge density, volume charge density. In mass also you have linear mass density, surface mass, and volume mass. Basically, you just have to divide by the appropriate dimension, length, area, or time. Okay. So for example, we can define a probability density as probability per unit length. This could be called as a probability density, dpx by dx. Okay. If it's a 3D world, then you can also say it is dpr. Let's say it's a function of r. Basically, r is a vector x I cap I j cap z theta upon d tau. This is the volume in that case. This is the volume element. So in 3D you can write it this way. Okay. In 1D you can write it this way. So that's also fine. Now, just a second. So what they do is they write a direct formula for probability density all the time. Okay. They say that probability density, which is dpx by dx, which we usually use, they write that it is mod of psi x square upon psi psi. Something like this. The question is obviously why. Okay. So let's try
for 1D.
For 1D.
Okay.
This formula will also be valid for 3D also. I mean, you can write it r, in that case, you have to replace it with r. I mean, you can write it tau here. So in that case, it just becomes r. So that's fine. Okay. So PD is dpx by dx, which is mod psi x square upon psi psi. Let's understand how this is correct. Okay. First, we just make a note of this formula. Okay. So people, we already know the formula for probability. What is probability? We learned in the morning. It was the value of psi. No, what did we write in the morning? Did we use integration formula? I think we use integration formula. No. What formula did we use for probability? Did we write?
Mod psi and psi I.
That was basically probability of finding. Okay, hang on. So we have only learned discrete formula yet. We have to learn the integration formula for continuous systems. Okay, so we have learned mod psi and psi I this way. Don't write anything yet. I'm trying to figure out a few things. And upon psi I, we put it this way. Okay. Which makes sense. Okay. So people, what is mod psi n, psi I actually? What is psi I if you remember? C1 psi 1 plus C2 psi 2 plus Cn psi n. Okay. Upon psi I psi I. Good. So this is this of, I can write this further as, hang on. Open this, scalar product people. Sin into sin 1 will be 0, sin into psi 2 will be 0, sin into sin will be 1, orthonormal basis. I'm using this for orthonormal basis. Okay. So sin will be 0, sin psi 2 will be 0, sin will be 1. You are left with just Cn now. You're just left with Cn. Okay. So I can say this is Cn square upon psi I psi I. Or mod Cn square psi I psi I. That's also fine. But then that's probability density. Don't write anything like I said. Probability, if I define using integration formula, we know it's psi star psi dx. That's probability. Okay, so I can also say this is probability is nothing but integration of dpx. So this would be psi star psi dx upon psi psi maybe. No. So this would be when I want to calculate probability from A to B, and then I have to divide it with the normalization condition. Correct. Okay. Let's do one thing. This is not required. And here, this definition is fine. So we have learned probability that a particle exists between A and B. That's basically P of x. P of x. So this is integration of A to B of psi star psi dx upon integration of psi star psi all space. Like it depends like what you have given. So this value is usually 1 if psi is normalized. So that's fine. Denominator becomes 1 in that case if psi is normalized. Okay. This we have written before. This we have done. Okay. Earlier in the very first class or before that of this particular chapter. Now, so this I can write this as AB into psi star psi dx. This is also dx. This is only from A to B, and this is the overall space or whatever reason they are giving. Whatever is this. If this is normalized, then this will be 1. If this is not normalized, then this will not be 1. That's important to understand. Okay. So this is nothing but scalar product of psi with psi. This is scalar product of psi with psi. Oh no, hang on. I still have a lot of confusion in my head. Don't write anything. Again, the morning formula, the correct one which we have written is psi n psi square, and we have written psi psi. So if I just want to use this for our idea, then I would write psi n star psi. This is more better. Dx, good. And mod, I have mod, and I have square. Okay, and I have psi psi. So that's psi star psi dx. Okay, that's fine. Okay, I think we are getting this. So this would be psi n star psi. Psi would be C1 psi 1 C2 psi 2 Cn psi n. It goes on, and I will have. It looks so incomplete right now to me. How can I just write mod psi x square? Maybe this formula is wrong then. I will just say, okay, let's do one thing. Let's just skip this temporarily unless I reach a numerical. After numerical, I'll be able to tell you for sure what exactly you want. As of now, just define probability density. Don't say anything. Just copy this. Don't write anything there. I will verify this when we reach a numerical. I'll have to go through the theory probability once more. Put a question mark there. Let's put a question mark. We'll come back to it later. Okay. Let's take a question for the morning. No, again, not that. Proceeding ahead. Please give heading types of scalar vectors. Types of state vectors. Okay. So people, there are two types of state vectors. Usually we define in quantum mechanics. Psi can be represented using position state vector. Position state vector, which is going to be the case throughout our syllabus of JAM people, where psi is a function of position and time. That's it. This is known as position state vector. In 1D you can write x comma t, in 3D you can write r vector comma t. Either way, it's position state vector. And another possibility is momentum state vector. You may have learned this in your BSc, but it's not a part of our JAM. So relax. Where you, instead of using position, you express everything in momentum space. You have something called momentum space instead of having a position space. So we will have psi of px comma t in 1D, or you can also write psi of p vector comma t in 3D. So that's also fine. Make a note. So there are two state vectors, position state vector or momentum state vector. What we are going to do throughout our JAM syllabus is position state vector only, where psi will be a function of position and time both. Where psi will be a function of position and time both. And remember, this is only the second slide. First slide is only this, where we have just defined a probability density. I want to verify the formula, that we will do that later. Okay, next. Proceeding ahead. Principle of superposition. Principle of superposition. Yes, in quantum mechanics also we have this. Because obviously wave function is quantum mechanics, it means you're studying the properties of the particle as a wave. Don't forget that. So you can have principle of superposition here also. So physical state of a system when we define. When you say physical state, what does that mean? Wave function. I told you in the classical world, the state is studied using position and momentum. But in quantum world, state is studied only using wave function. That's it. All you require is wave function to be studied. That if you have wave function, you can calculate energy, you can calculate momentum, you can calculate all the other variables. Hence, you call this a state function also. So the point is, any state function, instead of being written uniquely, like instead of being written an exclusive expression, you can also express it as linear combination of all the other individual wave functions. That also we learned in the morning also, for example, that a wave function is nothing but linear combination of its own eigenvectors. And eigenvectors are eigenfunctions in itself. So that is nothing but principle of superposition, people. Like you can write a wave function psi x as linear combination of many other psi I. And all these are nothing but what people, all these are psi I when you say eigenvectors only. Psi I are nothing but eigenvectors. So it's linear combination of all the eigenvectors. Simple. You can write this as C1 psi 1 plus C2 psi 2 plus Cn psi n. So this is nothing but principle of superposition kind of stuff only, right? If you have a wave function psi 1, if you have a wave function psi 2, if you have a wave function psi n, if they interfere with each other, then you can get another wave function psi p. That's nothing but principle of superposition. Make a note. Just a minute. Next, please be ready. Time evolution of a system. Time evolution of a system. See, if only if we had enough time right now, we would have derived this. But obviously, there are certain things. If I think we can skip without affecting our flow, we will skip it. So I have to skip the derivation of this. So the point is that if suppose system state, let the state of the system be psi of t naught, initially. Okay, initially. So t naught is the initial time. Okay, and similarly, let the state of the system be psi of t after time t. Okay, at time t. This is initially means at time t naught. So the question is how psi t varies with psi of t naught. That's the question. Time evolution. So what is the difference between them? That's what you want to understand. Let the state of the system be psi t naught initially, and let the state of the system be psi t at time t. This is time evolution of state of a system. State of a system. The relationship is very much clear here, and that is the value of psi t is directly written as E minus I t upon h cat into h cap into psi t naught. Or you should write this as t minus t naught. Write this as t minus t naught. They are assuming t naught is 0 right now. Into h cap. H cap is your Hamiltonian operator. H cap is your Hamiltonian operator. This is it. This is how the wave function evolves with time. Make a note. H cap is the Hamiltonian operator, and psi is not in the power. If there is any confusion, please tell. So this is only the power. Okay, this is only the power e raised to, and then into is outside. E raised to power of this into we have got psi of t naught.
We have an iota in the power, right?
Yes, this is iota. Complex number. So if T0 is 0, people, if T0 is 0 initial time, in that case, this becomes just e raised to minus IT upon h squared into h cap as a Hamiltonian operator into psi of 0. If T0 is 0. And just replace T0 with 0, just replace T0 with 0. That's the initial condition. Not helping. Okay. Okay. Too much of noise. I cannot hear you anything. Too much of noise. So now understand the initial wave function that you have, that's always linear combination of its own eigenvectors. Like I explained in the morning, a white light is made up of so many colors. So all the colors will have its own eigenfunction, for an example, eigenvectors, whatever you want to call it. So this will have psi1, psi2, psi n. So the point is when h cap applies on psi1 people, you have to replace this with e1. So it's something like this, when we write h cap of psi1, it's like e1 psi1, no? Something like that. Energy operator, when you apply on wave function, you get the respective eigenvalue of the same wave function, no? Respective eigenvalue of the same wave function. So the point is that if suppose you're applying e raised to minus it upon h squared of h cap into, suppose you are applying this on psi1, the energy operator that you have h cap, this now gives you eigenvalue, energy eigenvalue e1 people. So this becomes e raised to minus it upon h squared of e1 into psi1. Okay, basically h cap here kind of x on psi1 people, you end up getting e1 and then psi1. Make a note. Similarly, if you have psi2, then you have e2 side. If you have psi3, then you have e3 side. Likewise.
Sir, repeat kar dena.
Sure. See, the point is how the wave function varies with time. First of all, we are trying to understand this. So whatever is the initial wave function that they have given you, okay? Like I said, a white light. It is made up of many combinations. It will be c1 psi1 plus c2 psi2 plus cn psi n. Okay. Now how that wave function evolves with time? Suppose you want to study. Okay. So all you have to do is you have to multiply the initial wave function with this. This is how it will evolve with time. Time evolution of a wave function. Okay. Now when you operate, like basically it's an operator, you're applying this operator on the wave function. So operator has an h cap, Hamiltonian operator. Hamiltonian operator is energy operator. So if you apply energy operator on the wave function, what do you get? You get energy eigenvalue, no? If you apply h cap on psi1, what do you get? E1 psi1.
Yes, sir.
That's it. So that's what is going to happen. So when this will be applied on psi1, you have E1. Similarly, if you apply this on psi2, you get E2.
Yes, sir. Thank you, sir.
No problem. So for an example, if you have something like this, suppose that I've given you an initial wave function. Okay, let's say it is 1 upon root 2 psi1 plus 1 upon root 2 psi2. This is initial wave function, psi of x comma t, position state vector. This is position state vector, psi of x comma t, but t is 0 initially. T is 0. But we are asking you find the position state vector after some time t. What is the position state vector after some time t? You already know the answer. How do we write this? This will be e raised to minus it upon h squared of h cap into psi of x comma 0. Substitute. So e raised to minus it upon h squared of h cap. What is it? Psi of x comma 0? 1 upon root 2 psi1 plus 1 upon root 2 psi2. So apply the operator inside. What do you have? Psi of x comma t will be equal to 1 upon root 2 outside. When people's first operator will apply on this function, what will happen? H cap 7 you get e1 people. No? So this will be 1 e raised to minus it upon h squared into h cap is going to operate on 7. So you have to replace this with e1 and now you have 7. Similarly, what is going to happen second time? When h cap will apply on c2, you are going to get e2 people. So this will be 1 upon root 2 e raised to minus it upon h squared, energy eigenvalue e2, and then you have 7. I hope you understood this with the help of the example. Clear? Tell me if not, please.
We are aiming to find the position of the system.
No. Nothing. This is just a state function only. But like I said, state function now can be called as two kinds of function. Position state function where it's what do you say? You're trying to measure everything in position space, x, y, z in time. And then there is momentum space where you have px, py, pz in time. So this is not in jam syllabus, momentum space. So we just have position space. So instead of calling wave function, you can also call it position wave function. Nothing else. It's wave function only. You can if this confuses you, you can delete position, but it doesn't matter. I've written x comma t, so it's a function of position in time. So this is the function of position, this is the value of wave function initially, and now this is the value of wave function after some time because time evolution of the wave function.
Last page.
Okay, means that basically using this time evolution formula, we can get the position vector of any function at time t. When,
not position vector, not position vector. It is position state vector. It means it is wave function.
Wave function. Yeah, wave function.
Yes, you can find wave function at any time t. That's it. Okay, so this is initial wave function, and using this operator, you can find wave function at any time t. Nothing else. The simple idea is you have the initial wave function. If you want to find what is the wave function after time t, if you want to find this, apply this. What is the wave function after time t? That's it. Okay, evolution. Let's take a question now.
Sir, 1 minute.
So this is just nothing but the wave function after time t, and it's very simple, nothing difficult. Initial is given to you. Apply the operator on the initial. It means you have to multiply this with what? E raised to minus it upon h squared t1. Multiply this with e raised to minus it upon h squared t2. In fact, next time you can write this directly. You don't have to do this calculation in exam. Exam is not asking you steps people. So if I ask what is the value of this, directly write e raised to minus it upon h squared into e1 and multiply this with e raised to minus it upon h squared t2. If you have another side 3, that will be e raised to minus it upon h squared t3. So multiply all the terms with an exponentially decaying term. That's it. E raised to minus upon h squared it upon h squared into respective energy. Simple.
So these psi1, psi2 are not required to be written in the form of vector. That is the vector sign.
No. We never write. We never apply vectors on wave function. No. Okay. Sure. Thanks. Let's take a question now, and this will help you to understand everything that we have learned since morning. So the question right now is, it's a very good question. In an infinite potential box with walls x equals to 0 and x equals to a, so it's 1D first of all. It's 1D. The wave function is given by this. So root of 2 by L, sin n by L. Okay. This is psi n. And the energy is this, En. So respective wave function has respective energy eigenvalue. So psi1 will have E1, okay, psi2 will have E2, psi3 will have E3, and it goes on. Next. The wave function at some initial time, t equals to 0, is given by this. So this is the initial wave function. If you want, you can write it specifically psi of x comma 0. So that is its initial wave function, which is 1 upon root 5L sine of pi x by L plus 2 upon root 5L into sine of 3 pi x by L. But the problem is, sir, how will we understand its linear combination of which two eigenvectors? How do we understand which is this eigenvector and which is this eigenvector? Psi 1, psi 2, psi 3, psi 5. Simple, no? Observe the question, people. Sine n pi x by L is psi n. Sine n pi x by L is psi n, people. So this is sine 1 pi x by L now. This is what? Psi 1. Sine 3 pi x by L now. This is what? Psi 3. But however, to require root of 2 by L. Do I have root of 2 by L here? No. Do I have root of 2 by L here? No. So some manipulation needs to be done. So let's do that. No? So I can write psi of x comma 0. What do I have? I have 1 upon root 5L. What do we need? We need root of 2 by L. Here I need root of 2 by L first of all. So let's multiply and divide by root of 2 by L. Okay. Root 2 by L I'm multiplying, root 2 by L I'm dividing. Does it affect our calculation? It does not. Okay. And they have given you sine pi x by L. Similarly, what is the second term? 2 upon root 5L. Okay. Again, what do I need? Root 2 by L, root 2 by L. So let's just get root 2 by L, root 2 by L. What do we have? Sine of 3 pi x by L. Simple. Okay. What do we see now? It's time pass, people. First of all, L gets cancelled. Root L gets cancelled. Root 5 into root 2. That's 1 upon root L. Okay? Root 5 into root 2. Now, what is this now? Root 2 by L sine 1 pi x by L. It means this is psi 1. I hope you have understood this. Because they have given us root of 2 by L sine n pi x by L is psi n. So root of 2 by L sine 1 pi x by L is psi 1. Similarly, root L gets cancelled. You have 2 upon root 5 into root 2. That's root 10. Again, root of 2 by L sine 3 pi x by L. This is what people psi 3. So initially it was a linear combination of just psi 1 and psi 3. I hope you have understood the initial wave function first. Take your time understanding right this much. Any question you have taken the screenshot in this write the wave function? This is given. This is given. Here. Okay. And now we just did some small manipulation. Because I want root of 2 by x, sine of pi x by L, root of 2 by L, sine 3 pi x by L. Similarly, if you had another, again multiply divided root 2 by L. Take your time understanding right. Tell me if you have any questions. Don't hesitate. Do not compromise. So the initial wave function is made up of only two kind of wave functions. It's linear combination of psi 1 and psi 3. So tell me one thing, if at all suppose this wave function collapses, so either you will have psi 1 or you will have psi 3. Either of them you are going to have. It means either you will have energy eigenvalue E1 or you will have energy eigenvalue E3 if the wave function collapses. Correct? So what are the possible energies we can get? Now we understand there are only two possible energies we can get. We can either get E1 or we can get E3. That's the first answer. First question is find the possible results of the measurement of the system's energy. We can either get E1 or we can get E3. After the wave function collapses. Measurement means what? You have measured it and you already collapsed the wave function. I told you, measuring means you have to turn on the lights. If you turn on the lights, the wave function will collapse into a single particle. You will have only one result. So either you will have E1 or you will have E3. You cannot have both. Okay. So we can get E1 or E3 okay, as our measurement. I hope this is understood. And you can also calculate E1 and E3. So they have given us En formula. What is En? En is n square pi square h square upon 2 ml square. N square pi square h square upon 2 ml square. You can temporarily call this as E0 or whatever you want. You can call this E0 or E1. So you want to find E1, find E1. So 1 square pi square h square upon 2 ml square, or you can say this is pi square h square upon 2 ml square. This is one possible energy. And what is the second possible energy? E3 people. E3 is 3 square pi square h square. 3 square pi square h square upon 2 ml square, or you can say E3 is 9 pi square h square upon 2 ml square. So these are the two possible energies we can get people. Either E1 or E3, because wave function will either collapse to psi 1 or psi 3, and the respective eigenvalues are either E1 or E3. Easy so far. Tell me if not any questions.
The previous slide.
Sure.
Yes, sir.
In exam, by the way, you don't even have to do this now. In exam, you could have given the answer in 3 seconds. Yes. Why? I will read this. I will see this. I will say 1 pi x by L E1. I will say 3 pi x by L E3. Khatam. Answer is E1 and E3. Because manipulation is done to understand the coefficients, people. So we did the manipulation here, root by root of L, just to understand what are the coefficients. But the coefficients are not significant to understand what are the energy eigenvalues you are going to get. They're not significant. So you could have directly written checking sin 1 pi x by L, sin 3 pi x by L. Answer is E1 and E3. Khatam. Clear? Shall we? Next. So the first part is okay. Second, find the corresponding probabilities of having those results. So that I have taught you in the board. So we want to find probability of finding energy E1 or probability of finding energy E3. Let's do this. So probability of finding energy E1, or you can say probability of having wave function psi 1, however you want to call it. So how do we find this? This will be psi 1 into initial wave function, the whole square upon psi I psi I. Denominator will become 1 if at all our wave function is normalized. So if you want, you can check it immediately whether the wave function is normalized or not. You can check square and add these two. If at all by any chance, not these two, sorry. Square and add these two. This is our wave function. Okay. So if at all this becomes 1, then only you can say that the wave function is normalized. Let's check. I hope you remember the condition from the morning, C1 square plus C2 square. This was supposed to be 1 for normalization. Okay, so let's check. So 1 upon root 2, 1 root 10 square plus 2 upon root 10 square. So this is 1 by 10 plus 4 by 10. We are writing 5 by 10. So obviously this is 1 by 2, which is not equal to 1. Since this is not 1, you can say it's not normalized. The wave function, the initial wave function is not normalized, right? The initial wave function is not normalized. Okay, the initial wave function is not normalized. Then people. Okay. By the way, so since it is not normalized, we can also write the direct formula again from morning. If you remember, this comes out to be just C1 square, and denominator is now, because it's not normalized, it will be C1 square plus C2 square, and it goes on. But I know you have only two wave functions. You can write C1 square plus C3 square. Call it now. Say this is C1 psi 1 now, and say this is C3 psi 3. Write it. Linear combination of eigenvectors C1 psi 1 and C3 psi 3. There is no C2, there is no C5. Okay. So this is probability, right? I have also told you that this square we are writing because the values are real, right? They are not complex. If they were complex, then you know, instead of writing square, you have to write star and that. Like C1 square should be written as C1 star C1. If at all they are complex, if at all. They are not complex. So I am directly writing C1 square. So let's calculate what is C1 people. C1 is 1 upon root 10 and what is C3? C3 is 2 upon root 10. Let's calculate. So C1 is 1 upon root 10 and C1 is 1 upon root 10 and C3 is 2 upon root 10. 2 upon root 10. That's it. So what do we have? This is 1 by 10 upon 1 by 10 plus 4 by 10. So we have 1 by 10 upon 5 by 10. 10 gets cancelled, 1 by 5, or probability is 0.2. Got it, people? Probability of having the energy eigenvalue to be recorded as even after the measurement. Like suppose initially you have a wave function, it is made up of two colors, let's say, suppose blue and green, the same. So the chances that we will get blue is only 0.2. So automatically, what will be the chances that we will get green people? It has to be 0.8. Don't you think 1 minus 0.2? We can check. It has to be 0.8. You can directly write. Because luckily there are only two wave functions. So if you have one, you automatically get other for free, 1 minus answer. And there are three wave functions, people, 1, 2, and 3. In that case, you need to find 2 to directly say that the third will be 1 minus the sum of 2. Right now we just have two values. So I can just say this is 1 directly. Answer has to be 0.8, but let's check. What is the probability that I will get the result? What's the probability that I will get the result? E3. Or you can say what is the probability that the wave function will collapse to psi 3, whatever. Okay. So the answer will be C3 square upon C1 square plus C3 square. So 2 upon root 10 the whole square upon 1 upon root 10 the whole square plus 2 upon root 10 the whole square. I hope you are with me. So this is 4 by 10 upon 1 by 10 plus 4 by 10. So we have 4 by 10 upon 5 by 10. 10 gets cancelled, we have 4 by 5 as expected people 0.8. We could have written this directly. You could have directly written answer has to be 1 minus probability of psi 1 because there are only two wave functions here. There is not a third wave function. So sum of both has to be 1. It's either this or this now. There is no other way. So total sum must be 1 anyway. So in that case, we would have got the result directly here. Okay. And if you want to write the general formula, in that case, general formula would be psi 3 into initial psi I. Sorry. General formula would be psi 3 into initial psi I, the whole square, the whole upon psi I psi. But we don't have to use the general formula, I have told you, unless our wave function or unless something else has happened. Let's say for non-orthonormal cases. Remember, you get this as far as the denominator is orthonormal because psi 1 becomes 1, psi 2 becomes 1, psi n becomes 1. So you get C1 square, C2 square, C3 square, you get that. So this formula is valid only for orthonormal cases. If you don't have orthonormal cases, you won't get this formula. Any questions, anyone, anywhere, please ask. Take your time. Don't hesitate. Tell people, shall we? And write it again if you want, that we can use this trick for orthonormal cases because denominator, you are assuming that psi 1 will only multiply with psi 1 and you'll have C1 square. Psi 2 will only multiply with psi 2 and you'll have C2 square. You are assuming that. So it's valid only for orthonormal cases. Next. Okay, proceeding ahead. So this is also done. Find the corresponding probabilities of having those results. Now, find the form of wave function after those respective measurements. Basically, what is the meaning of it? Find the collapse wave function. What is the wave function after we measure those? After the measurement, what is the collapse wave function? That's what we want to calculate. Let's calculate the collapse wave function. So what is the equation of the collapse wave function? People, psi after. Psi after was psi n. No, it was something like psi n, and then scalar product of psi n with psi I upon psi I psi I. But denominator is not 1 psi, so we have to calculate this. Okay. So it depends that what we have measured. If we measured, let's say E1, then psi after is psi 1. Okay, like we want to calculate what happens if you measure E1, and if we measure E3, then we want to understand what will be the value of psi after. I hope you remember from the morning. Answer will be some multiple. It will be some multiple of psi 1 only. If you measure, suppose you have measured E1, you turn on the lights, you record it, you got the value E1. So the wave function will be some multiple of psi 1. What is that multiple? It's not necessarily this. It will be this in which case, people. Normalized. You could have written answer. The collapse wave function is 1 upon root 10 psi 1 if the wave function was normalized. Sadly, it's not normalized. No? Similarly, I could have written that the answer is 2 upon root 10 psi 3 directly if the wave function was normalized. Sadly, it's not normalized. So I cannot say that this is the collapse wave function, this is the collapse wave function. However, it will be some multiple of psi 1. So that we can check using the original formula psi after. So let's write case 1. If we measure E1, or basically you can say psi 1, the corresponding wave function is psi 1. So what will be psi after? Psi after the measurement. Okay. So psi n is psi 1. Psi n is psi 1. You have to multiply this with psi I. What is psi I? Psi I is 1 upon root 10 psi 1 plus 2 upon root 10 psi 2. The whole upon psi I that we have calculated already. That's it comes out to be 4 by 10. No, sorry. What does it come out to be?
1 by 2.
1 by 2, no, that I So this one you already calculated 1 by many times. So it is square right now. Or because you're writing this formula, you can write it for one time. So 1 upon root 10 psi 1 plus 2 upon root 10 psi 2. You have to take the scalar product with itself. 1 upon root 10 psi 1 plus 2 upon root 10 psi 2. Okay. Any questions, anyone, anywhere? Let's calculate. So what do we have? Psi after. This is equal to psi 1 will multiply with psi 1. Psi 1 and psi 2 will become 0. So we have psi 1 into psi 1 will be 1 orthonormal basis and left with 1 upon root 10. And psi 1 psi 2 will become 0. In the denominator, we have again psi 1 will multiply. Okay, 1 upon root 10 into 1 upon root 10, that's 1 by 10 plus psi 2 will multiply 2 upon root 10 into 2 upon root 10, that's 4 upon 10. Okay. So we are getting 1 upon root 10 times psi 1, the whole upon 1 by 10 plus 4 by 10, which is 5 by 10. So we are getting 1 upon root 10 of psi 1, 1 by 2. 2 goes in the numerator. The answer is 2 upon root 10 of psi 1. This is the collapse wave function. 2 upon root 10 of psi 1. Ask me if you have any questions, don't hesitate.
Yes, sir.
Okay. Similarly, what will be the psi after if case 2 people, if you measure E2, do that. Case 2, if we measure E2. Good. If we measure E2. So psi after would be, again, you can directly understand what you take basically in the previous time. It has to be some multiple of psi 2, that's what you understand. Okay. So the thing is, this thing, as we just understood, where is it? 2 upon root 10 is going to be there, but in the denominator, we are going to have that additional 1 by 2. You know? So as per what we just observed, 2 upon root 10 will be there, but in the denominator, we'll have basically C1 square plus C2 square. So that I think maybe we can take it as a small trick. So our answer here becomes 4 upon root 10 of psi 2. Clear, everyone? Please tell me if you have any questions in the chat box. So we have just got a message from Neeraj sir that he will not be able to take the class due to fever. Okay. It's a good temptation, sir, ma'am. Let me think. I don't mind, but it's our starts from 6:45 to 8:15 now. Okay, I will take the second class. No problem. But wait, sir, just a second. It depends on students also because they have already attended morning class, evening class. Are they willing to take a third class?
Yes sir, definitely sir.
But no, wait. Those
सर
are
नहीं होगा तो भालो
हाँ क्या बोल रहे हो? नहीं होगा,
नहीं होगा तो भी अच्छा होगा
तो भी अच्छा होगा. That's what I'm also saying. Because
आज नहीं लेना
क्लास हो
सर
गया सर यस
सर
सर
एक वैसे मिस हो गया मेरा
यस यस सर टुमारो नॉट टुडे
सर कल लेना लेना
No, that's it's not about tomorrow. No, it's just that tomorrow sir will be happy. But the thing is, today he is in, so we don't have the second class. But I understand because we have already 2 classes, it might just become a bit more saturating. So we will keep the second class. We can give them a holiday. Okay, like after my class. Imran sir. Okay, okay. So we will just take this class. So we have proceeding ahead. See, being a student, I also understand the fact that quantum, even though no matter how much you enjoy, you are learning all of this for the very first time. 3 lectures a day, it might just become.
Yes, sir. मुझे थोड़ा सा वक्त चाहिए समझने में.
Exactly.
पहले पढ़ रहा हूँ मैं तो इसमें.
So it's like I understand. Okay. ठीक है. Okay, proceeding ahead. So I have to people this is also calculated.
बस सर मेरे को भी मैसेज नहीं आया
वो मेरे को सर को आया
मुझे आया प्राइवेट मैसेज चला है वो
हाँ,
ये तो
that is the-
मैसेज चल रहा है. नहीं सर, I'm not taking the class. I'm not taking the class at 6:45. हाँ सर.
तो वैसे सर आप ये छोड़ दिया
सर
क्लास
साइमल्टेनियसली बात कर रहे हो आप हमारे साथ भी उसके साथ भी
हाँ yes, simultaneously चल रहा है. Okay, चलो proceeding ahead. Next. Case 2 that's also done. Okay. Proceeding. So find the form of wave function after those respective measurements. That's also done. Next. If the energy is measured again immediately afterwards, what are the probabilities of the possible outcome? Well, this is time pass. Actually, there is a small thing which I'm worried about. Hang on. If I think about probability, just a minute, people. Psi after is psi n, psi I. That's fine. We divided this with psi I, which we have to. So we got 2 upon root 10 and 4 upon root 10 respectively. Now, if I speak about probability, so I will have 1 upon root 10. This is initial. I will get 16 by 10. The crosses month. Let me check. I'm hating this already. We did nothing wrong. Psi after we have calculated. This is the initial value. So now if I worry about the probability, but this is not normalized obviously. So that would be 4 upon root 10 square. The whole upon. That would be 16 by 10. No. Probability that I will have even value and probability that I will have E2 value. 2 possibilities. Which question is this? Screenshot. Okay. Probability, it should be 1 or 0, either of them. But if I write, let me think, probability of measuring psi 1, this would be the formula that we have learned is psi 1 psi I upon psi I psi I. Okay. Psi 1 psi I, which is 4 upon root 10. Okay, it's correct. Good, great. Okay, listen. So the thing is, now we are asking, it's simple. We had got a wave function, like I said, let's say it was made up of 2 colors, green and blue, like I said, and after measurement, you got only 1 color. Suppose you got only blue color, just one of the color. It means that the color was collapsed to one of them. You measured blue. Now they're saying after some time, if you again measure, what will you see? Absolutely, we are now going to see blue forever for the rest of our life. Once the color is collapsed, we are going to see that blue for forever. So what is the probability that I will get blue now? 1.
one
And what is the probability that I will get green?
0
0. Correct? So if the color value was collapsed to green, if suppose after measurement you got green color, then probability that you would get green again is 1, but the probability that now you would get blue is 0 because it's a collapsed wave function. It's not linear combination of any wave functions anymore. So I'm just checking whether mathematically we are getting that or not, but we are getting, so that's good. So case 1, people. Case 1. If wave function was collapsed, so like let's say psi after, basically psi after. So what was that value in case 1? 2 upon root 10 of psi, okay? 2 upon root 10 of psi. Okay. Now this. So now they are saying after some time, you have already measured this, huh? We have already measured it after measurement. This is after measurement. Now they are saying if you again measure, then what is the probability of getting psi 1? What is the probability of getting psi 3? I already told you now probability if we again measure. I will write if we measure again. It's only very logical, but mathematically I was worried that we are not getting the result, but we are getting the result. I misunderstood it. Okay, so if we measure again, then obviously what is going to happen, people? Just a minute. Then probability that I will get psi 1, it is 0 because there is, sorry, it has to be 1 because it has only psi 1 now. And probability that I will get psi 3, it has to be 0. It's logical, but I was thinking, are we getting this mathematically or not? Well, we are. Have a look how. So probability of psi n, what is the formula? The formula is psi n psi I upon mod square upon psi I psi I. Okay? So probability that I will get psi 1, people. Probability that I will measure psi 1 now. Okay? What is the probability that I will get blue color again? It's simple. Substitute. What is psi n now? Now this is psi n now. Sorry, not psi n. Psi n is just psi 1. But what is psi I now? Initial wave function is in the wave function just before the measurement. So if we measure again, what is the wave function just before the measurement? This is the wave function, right? 2 upon root 10 sin. 2 upon root 10 sin. I hope you understand. Tell me. Now this is psi I. You can write if you want. Now this is psi I. Okay, and now we are measuring again. So now this behaves as initial wave function, right? And now we are going to measure again. So let's substitute the whole upon, and there is a square here. The whole upon psi I. So what is psi I? 2 upon root 10 psi 1. Okay, and what is psi I? 2 upon root 10 psi 1. I hope you are with me. Tell me any questions first of all. Probability that I will measure blue color is blue color into the total. That's it. Probability that I will get psi 1 is psi 1 into total. But the thing is, total itself is 2 by root 10 psi 1. Okay, psi 1 will be 1. What are you left with? 2 upon root 10 mod square. Also, psi 1 will be 1. What am I left with? 2 upon root 10 into 2 upon root 10. What is the answer, people? 1. Understood? Confused? Got it?
Yes, sir.
Yeah, now mathematically and logically. Go.
Got it. Good. Similarly, if you would have written psi 2, answer should have been 0. See, it is 0. Why? Because if this is psi 2, then who becomes
Numeric
psi 2?
itself is 0.
Yes,
Because this
and
becomes psi. That's it. Numerator will become 0. No, psi 2 psi 1. So probability of getting psi 2 will become 0 in that case. Copy this. Nice. I was initially just squaring the coefficient, and I got worried that if I square it, I'm getting 4 upon 10 here. That was not a problem. Problem was the second case, where I was thinking I'm getting 16 by 10, probability that's insane. But I forgot this is not normalized. So you have to divide by the same wave function once again. You can say answer is C1 square is probability if you remember only for normalized wave functions. Otherwise, what is the probability equal? C1 square upon C1 square plus C2 square, no? Or plus Cn square. Okay, now it's fine. A lot of data in the head. Any questions, anyone, anyway? Please ask. Then people shall we? Also write for psi 2. Please write for psi 2 with the formula. So this becomes psi 2 then, okay? And answer would be 0. Psi 2 psi 1 becomes 0. Clear, people? And similarly in case 2, psi after was 4 upon root 10 of psi 3. Okay, so that's it. Now probability that I will get psi 1 is 0. Now probability that I will get psi 3 is 1. Directly you can write. Any questions, anyone? Please ask. Clear, people? So this numerical I hope again help you to understand everything that you learned since morning. Now, next part. I will take another numerical immediately, I think so. Let's take another question and maybe gain good confidence on this. So we have got this. Let psi n denote the orthonormal stationary states. That's good. Orthonormality is mentioned. Corresponding to energy En. Okay. Suppose that the normalized wave function. Okay, so the wave function is also normalized outstanding. At t equals to 0, this is the initial wave function. Okay. Okay. Suppose that a measurement of the energy yields value E1 with probability half, E2 with probability 3 by 8, and E3 with probability 1 by 8. First of all, they're asking like the most general expression of this. People, we learned in the morning. So this can be written as what? First of all, linear combination of its eigenvectors. Linear combination of eigenvectors. Which are the possible eigenvectors? You are measuring E1, you are measuring E2, you are measuring E3. So the possible eigenvectors are psi 1, psi 2, and psi 3 corresponding to energy eigenvalue E1, E2, and E3 respectively. So it will be linear combination of psi 1 plus psi 2 plus psi 3. Okay. But we need, when they say most general expression, we need the value of C1, C2, and C3. Do you remember what is the formula of probability of measuring psi 1 if the wave function is normalized, if the states are orthonormal? What was it? Normalized and orthonormal states.
C1 square plus C2 square plus C3 square.
So C1 square upon C1 square plus C2 square plus C3 square. That's the probability of psi 1. Correct? For if the wave function, if the wave function is normalized, then denominator is what? Just check.
Yes, sir.
Yes, sir. Only C1 square.
Yes, sir.
C1 square is allowed.
Okay.
No,
But I still want to check this. Check, sum of square. Are we getting 1 or not? Even though you have mentioned normalized, actually this should not have mentioned. It would have been good to just check. Just check. So 1 by 2 square plus 3 by 8 square plus 1 by 8 square. It should be 1. So 1 by 4 plus 9 by 64 plus 1 by 64. I need 64 now. So multiply and divide by 16. So 16 upon 64 plus 9 upon 64 plus 1 upon 60. Am I doing this correctly?
Yes, sir, you are
Yes, sir.
Yes, sir. But it's not
doing
normalized.
no
Then.
one.
It's not normalized.
It won't be 1.
It won't be 1. It cannot be normalized. So okay, so it's wrongly written. Simple. It cannot be 1. Let's write this then. This is C1 square. But now I have multiple questions. It cannot be normalized, absolutely. But then it cannot be normalized, absolutely. No, but then okay. So what is the answer here? 16 plus 9, which is 25, plus 1, which is 26 upon 64, which is 13 upon 32. Okay. 1 by 2, 3 by 8, and 1 by 8. 1 by 4, 9 by 64, 16, 25, 26. Perfect. Okay. So, but I need C1, C2, C3 still. Okay, so let's find what is probability of E1. Answer is C1 square upon C1 square plus C2 square plus C3 square. And what is probability of E1 they have given us? It is half. It is half. So half is equal to we have got C1 square, which we want to find. And what is C1 square plus C2 square plus C3 square is 13 by 52. So we have got 1 by 2 into 13 by 52. This is C1 square. So C1 is
32.
32. It is 32. Okay. So I could not understand my own handwriting. Nice. 32. So we have got 13 upon 64. 13 upon 64. So C1 is under root of 13 by 8. We are getting real values, but that's okay. I'll also just verify the question for once. Which is this question? Similarly, calculate C2 and C3.
सर
बोलो।
सर हमें प्रोबेबिलिटी दे रखी है तो प्रोबेबिलिटी 1 होनी चाहिए सर तीनों का ऐड C1 स्क्वायर C2 स्क्वायर थोड़ी 1 होना चाहिए वो तो सर निकाल ले हमें
हाँ सर, probability given थी ना हमें.
Yes, sir.
तो
Probability
उसका
बनी है.
उसका
उसका
sum
सम बना रहा है वो आ रहा है सर अपन सर C1 निकाल रहे हैं उसका स्क्वायर कर रहे हैं
No comment. ठीक है. Okay, correct. So hang on. Okay, so when you say normalized, normalized basically means that the value of psi will be 1. So the value of normalized और probability का क्या connection है? I'm also confused right now. They have given us probability of even. What is probability of even? They have given us it is half. Okay. If I use the general formula c1 square upon c1 square plus c2 square plus c3 square, this is half. How do you proceed after this then? If I calculate probability of e2, okay, which they have given us how much? Probability is 3 by 8. But then it is c2 square upon c1 square plus c2 square plus c3 square. This is 3 by 8. Okay. And if I proceed with probability of e3, then this is c3 square, which is c1 upon c1 square plus c2 square plus c3 square. And this they have given us, which is how much? 1 by 8. So obviously, if you will add them, then they will get cancelled. Probability will become okay. It becomes 1 then. P probability of e1 plus probability of e2. बोलो.
यहाँ पे नॉर्मलाइजेशन कंडीशन है ना, तो c1 स्क्वायर प्लस c2 स्क्वायर प्लस c3 स्क्वायर इक्वल 1 बना। आप ही ने सुबह बताया।
Yes, sir. और C1 1 by root 2, C2 1.
But the point is that it's not coming out to be 1. That's what I'm saying. That's what we checked.
आ तो रिया सर 1 C1 स्क्वायर 1 by 2 आएगा ना सर? 1 by 2 को
अच्छा, हम c1 स्क्वायर का भी स्क्वायर कर रहे थे।
Yes sir.
तो ये बोलो ना, कि हम c1 स्क्वायर का भी स्क्वायर कर रहे थे। c1 स्क्वायर is half. It's not that c1 is half. Now it's fine. Now it's absolutely fine. Okay. So gist of what we are supposed to write is that nothing. Erasing, you will have to cancel so far. So question is only this. Now it's fine. Okay. Normalized wave function. So for normalized wave function, probability of En is Cn square for normalized wave function. Good. So probability that I will have energy value E1, they have given us it is half. So this will be C1 square. So C1 is 1 upon root 2. It's not 1 by 2. Probability that I will get energy E2, it's how much? 3 by 8. So this is C2 square. So C2 is root 3 by 8. I hope you realize what we did. C1 square the whole square, we did C2 square the whole square and C3 square the whole square, and we were checking whether it's 1 or not. Okay. So probability of E3, this is 1 by 8, which is C3 square, and C3 is 1 upon root 8. Okay. Good. We got the concepts. And just for our satisfaction, is the probability coming out to be 1 or not? Total probability. Probability of E1 plus probability of E2 plus probability of E3. It should be 1 now. It should be 1. See if you are getting 1 or not. So it is half plus 3 by 8 plus 1 by 8. So this is, I can write half as 4 by 8 plus 3 by 8 plus 1 by 8, which is 4 by 8. You are getting 8 by 8, which is 1. So probability is coming out to be 1. Just checking, and we checked it. Also, sum of C1 square plus C2 square plus C3 square, that should also be 1, which is actually the same thing here. Probability C1 square which is half, probability C2 square which is 3 by, probability C3 square which is 1 by 8. Again, this is also 1. So everything is sorted now. Make a note. It was a one-line question. It's not confusion. But still, tell me if you want me to repeat anything. Don't hesitate.
Just re-explain it.
Sure. So, in the question, we have mentioned that the states are orthonormal. That's good. Wave function is normalized. Outstanding. For a normalized wave function, we learned probability of En is this. If it is not normalized, then we would divide with C1 square plus C2 square plus Cn square. If it is not normalized, but luckily it is normalized. Okay. So probability of E1 they have given is half. Probability of E2 they have given 3 by. Probability of E3 they have given 1 by 8. So C1 square is half. C2 square is this. C3 square is this. C1, C2, C3 we calculated. Question is done. But still, for our satisfaction, regarding all the properties that we know, I wanted to verify a couple of things. Some of all the probabilities should be 1. So I just wanted to check whether it's 1 or not. What I did initially idiotically was I calculated half square, 3 by 8 square, and 1 by 8 square. That's wrong. The sum of probability is 1. And probability they have given us is half, 3 by 8, and 1 by 8. So just check there as well. Okay. So it is 4 by 8 plus 4 by 8, which is 1. So yes, sum of probability is 1. Also, if you remember, like I said, here why don't we write the denominator? Because it's normalized. So for normalized, we learned in the morning that the denominator will be 1. So the question was, is it 1 or not? Yes, actually, because sum of probabilities means the sum of square of C1 square, C2 square, C3 square. No? So if sum of probabilities is 1, then sum of C1 square, C2 square, C3 square, that will also be 1, and we don't have the denominator. So everything that we learned is now fitting. Clear now?
Yes, sir. Yeah.
Okay, great. Others, please ask if you have any questions. I will still take again one question. Unless we are going to do a question with a word flow, we won't stop. We'll take another question.
Just the part B है.
Part B time pass. So initial wave function is done by the way. So what is C1? C1 is 1 upon root 2. What is C2? C2 is root 3 by 8. Okay, and psi 2. And then what is C3? C3 is 1 upon root 8. Psi 3. So this is first part. Okay? Your answer. Answer to the first part. They ask now and the most general expression. So this is the answer. The most general expression. Copy please. And be honest if you have a question. I told you if you don't want to ask it in front of class, you can text me personally in the chat box.
Yes sir.
Okay, sure. Next. So now write a most general expression of psi of x comma t. This is what time evolution. Now it's only time pass people. We already have psi of x comma 0. What is psi of x comma 0? It is 1 upon root 2 psi 1, and then we have root of 3 by 8 psi 2, and then we have 1 upon root 8 psi 3. So people, what is psi of x comma t? Psi of x comma t. If you remember, it is e raised to minus it upon h cut into h cap into psi of x comma 0. But this is only a step. You can write the answer directly. When h cap will multiply on this, you get e1, h cap on this e2, h cap on this e3. So psi of x comma t is 1 upon root 2 e raised to minus it upon h cut into e1 into psi 1 plus root of 3 by 8 e raised to minus it upon h cut into e2 into psi 2, and then 1 upon root 8 e raised to minus it upon h cut e3 into psi 3. Clear people? See, quantum, I hope you have been realizing so far it's easy, but all you need is practice. It's not difficult. It's just mathematics we are dealing with. And the greater you will take number of problems, lesser will be the confusion. So you just have to solve. Shall we?
Yes sir.
Yes, sir.
Let's take another problem. Okay. So we have been given The components of the initial state psi I of a quantum state are given in a complete orthonormal basis of three sets. Okay, orthonormal basis of three sets are given. Phi 1 psi I is I upon root 3, phi 2 psi I is root 2 by 3, phi 3 psi I is 0. Okay, calculate the probability of finding the system in a state psi f whose components are given in the same basis by this. Okay, let's get started. What are they asking? They're asking us calculate the probability of finding the system in the state psi f now. Apply the formula of probability. What is the probability that I will get psi f? It is mod of psi f into initial psi I the whole square upon psi I psi I. Okay. Now let me think. So when we will apply psi f on psi I, we will have psi f phi 1. What is psi I? Components of initial state. Okay, psi I is okay. And what phi 1 psi I? Okay, let's say this is equation 1. Now listen, initial state has got three orthonormal bases. What is the meaning of three orthonormal bases? It is linear combination of all of them. So I can say psi I is linear combination of C1 phi 1 plus C2 phi 2 and C3 phi 2. We don't know the value of C1, C2, C3 now. C3 phi 3. Why? Because they have mentioned its orthonormal basis. I told you orthonormal basis basically forms linear combination for any wave function. So this they have given us. But we have no idea about the value of C1, C2, C3 yet. We can calculate that. How? Let's start with the first. Phi 1 psi I equals I by 3. Okay? They have given us that phi 1 psi I is how much? I by 3. Simple. Nothing to worry about. Substitute. Phi 1 into what is psi I? Psi I is this, right? Psi I is C1 phi 1 plus C2 phi 2 plus C3 phi 3. Okay? Or you can just write directly C1 phi 1 plus C2 phi 2 plus C3 phi 3 and just put a greater get bracket. This is I upon root. But they have mentioned these are orthonormal bases. What is the meaning of orthonormal? Psi 1 will multiply with psi 1, psi 1 psi will be 1, psi 1 psi will be 0, psi 1 psi will be 0. Correct? What are you left with? C1, that's it? Hello? C1 is I
Yes,
upon root 3. Matlab, they have given you C1, C2 and C3 पूरा घुमा फिरा के. It's directly C1, C2, C3. Have a look. Phi 1 psi I is I upon root 3. It means C1 is I upon root 3. A different way to write it. A very beautiful way to write it. So in general, we can just say that if I want to write Cn, it will be what basically phi n psi I. So nice. Cn is the eigenvector corresponding to this phi, like C1 phi 1, C2 phi 2, C3 phi 3. Nice, no? Make a note. So similarly, I can say C2 is directly given to us. Okay, C2 is root of 2 by 3 directly, and C3 is directly given to us at 0. Very interesting. Tell me if you have any confusion there. So phi 1 psi I is I upon root 3, so C1 is I upon root 3. Similarly, phi 2 psi I will be whatever. Phi 2 psi I was root of 2 by 3. So C2 is root of 2 by 3, no? Because when you have phi 2, what you will have here? Phi 2 phi 1 will become 0, phi 2 phi 2 will be 1, and phi 2 phi 3 will become 0. You are left with C2 again. You are again left with C2. So C2 will be RHS, and then C3 will be RHS. Is it clear, people?
Yes, sir.
Good. So nice way to write. But remember, ensure that this is valid when the phi I, that phi 1, phi 2, phi 3 are orthonormal bases. Or you can say that I will write this thing very clearly for you. You can write this as a note that if we have some wave function psi I, okay, which is C1 phi 1 plus C2 phi 2 plus C3 phi 3, where phi 1, phi 2, phi 3 form orthonormal bases. Only in that case, you can write C1 itself as directly, this is phi 1, okay? C1 itself as directly of phi 1 psi 1. Nice way to write. So Cn we can write as phi n psi 1, psi I. Phi 1 psi I, then phi 2 psi I, and similarly phi n psi I. Any questions, anyone? Please ask. Write this as a note. A different way to write constants. A complicated way. They could have given us the constants directly, but basically they wanted students to scratch their head that how we can find the constants. See, I did not know this formula until now. I took the question, copy pasted from directly. I felt that it's a good question. A lot of things are asked. Okay. But then you just have to follow the process. Whatever they have given, you write those given, and then see, you know how to calculate this. So first I wrote this, then they have given us this. Then I thought, what should I do? I can substitute. They mentioned orthonormal. So just go with the flow. Don't scratch, think hard much. Okay. Proceeding ahead. So this is done. So our wave function is basically given. So psi I is nothing but I upon root 3 phi 1. Okay. And then root of 2 by 3 phi 2, and then 0. It's independent of phi 3. Wave function is independent of phi 3. I hope this much is understood. We found out C1, C2. Done, shall we? Next. So what is it that they're asking? They're asking us find the probability of psi f. So now it's fine. What is probability of psi f? It is, as we just wrote, psi f into psi I mod square upon psi I psi I. Okay. They have not mentioned, by the way, if you remember, whether it's normalized or not. They have not mentioned the normalization condition. Have they mentioned the question anywhere about normalization? No. So just to check the denominator, see whether this is 1 or not. But just calculate the denominator separately. Let's calculate psi I first, denominator. Basically, we are just checking the normalization condition. Okay. But you cannot, if you want to connect phi 1 will be 1, phi 2 will be 1. But just take care of a couple of things. You already know which part I'm talking about. I upon root 3 phi 1 plus root of 2 by 3 phi 2, and I upon root 3 phi 1 plus root of 2 by 3 phi 2. Okay, that's fine. So you have to multiply phi 1 with phi 1, that will become 1, phi 2 with phi 2, that will become 1. But can I write I by root 3 to I by root 3? What am I supposed to write?
So 1 star and I by root 3 star.
Yes. This is a bra vector. Okay. So I by root 3 star into I by 3. This is root of 2 by 3. This is real, so there is no problem. You can write root of 2 by 3 star, but it's real anyway. Beautiful. Now it's fine. So I by root 3 star, that's minus I by root 3 into I by root 3. This is plus root 2 by 3 into root 2 by 3 directly. Okay. So what do we have? Denominator is equal to I into I is I square. I square is minus 1. Minus into minus becomes plus. So that's 1. Root 3 into root 3, that's 3. Root 2 into root 2, that's 2. Root 3 into root 3, that's 3. It's a normalized wave function. Denominator is 1. Nice. Are you with me, people? Tell me if you have any questions. Good. Okay, shall we? So denominator is 1. So all that we have to calculate is now the numerator. So probability of finding psi f, it is now just mod of psi f psi I the whole square. And that's time pass. So that is basically psi f into what is psi I? Psi I is I upon root 3 phi 1, I upon root 3 phi 1 plus root of 2 by 3 phi 2. Any questions, please ask. Okay, the whole square. So this would be, now listen, I upon root 3 I can go outside without conjugate, no? Because this is on the ket vector side. So I can throw I upon root 3 without conjugate outside. Psi f phi 1. I hope this is fine. Tell me if not. And similarly, you can throw root of 2 by 3 also outside. And what are you left with? Psi f phi 2. The whole square. And by the way, the second lecture is cancelled already out. Psi f phi 1 and psi f phi 2. By the way, this is the property that we learned in the first chapter, if you remember, like MFQM, where we learned psi 1 into A phi 1 plus B phi 2, the distribution. That's what you're applying.
Yes, sir.
You can throw A outside and you can throw B outside while splitting. Okay. And they have given you these values. They have given you these values. So what do we have? Mod of I upon root 3. Psi f phi 1. What is psi f phi 1? Psi f phi 1 is 1 plus I upon root 3. No. Again, this is an outstanding. This is becoming such a good question now. They have not given us psi f phi 1. They have given us phi 1 psi f. Wow. They have given us phi 1 psi f. And we need psi f phi 1. What is phi 1 psi f? Phi 1 psi f is 1 plus I upon root 3. Okay. 1 plus I upon root 3. Can you tell me what is the value of psi f phi 1 then?
1 minus
1 minus
1 minus I upon root 3. Because I hope you remember this is nothing but phi 1 psi of the whole star. Again, the properties that we have learned are coming live, you know, like they're taking the words. We learned this, that phi 1 phi 2 the whole star can be written as phi 2 phi 1. These are the properties that we are using now. So psi f phi 1, it is nothing but phi 1 psi of the whole star. So if you just have to conjugate of this, 1 plus I upon root 3 the whole star, which is 1 minus I upon root 3. Outstanding. Okay, so psi f phi 1 we wanted, which is 1 minus I upon root 3. Nice. Plus root of 2 by 3 into psi f phi 2. What is psi f phi 2? Psi 2 phi is 1 upon root 6. This is real. Here you don't have a problem. Okay. So psi 2 phi f or psi f phi 2, they will be same because it's anyway 1 upon root 6. So that's real here. Good. You can directly write 1 upon root 6. Huh? The whole square. I hope you have written copy. Psi 2 phi f is real. No problem. Phi 2 psi f they have given us 1 upon root 6, which will be equal to, you can write, therefore psi f phi 2 the whole star, or this is phi 2 psi f the whole star. This is also 1 upon root 6. It's anyway real. So conjugate is not affected. Any questions? Anyone? Anyway. A gem of a question to understand quantum people. All the 3 questions are actually quite good. We took today. But you'll have to go through the theory of the morning once again and go through all the numericals once again. Going through might not help you just people that much. Resolving these problems can help you more. As in go through the theory of morning class and evening class. Go through the problems also of all the 3 problems that we have taken, and then try and resolve all the 3 problems. Because when you will be resolving now, then you might just be stuck at a couple of places. You might just make some silly errors, and only during then you will realize, okay, no, I understood this concept wrong. This is how I'm supposed to go through the problem, but then resolve it by yourself. After going through, resolve it by yourself. All the 3 that we have confidence in this can increase, and then solve as many problems as available in your book. So we're done. Shall we calculate the final answer? So mod of I into 1, which is I upon, which is just I into I. Minus of I into I, that's I square. Root 3 into root 3, that's 3, plus root 2, root of 2 upon 3 into 6, the whole square. Okay, and just open the brackets, nothing else. So I minus I square, that's minus 1 upon 3, plus this is 2 1, this is 2 3, root 3 into root 3, that's 1, so 7 by 3 square. Okay, so this becomes we have I plus 1 upon 3 plus 1 upon 3 the whole square. So this is I plus 2 upon 3 the whole square. But remember, you are calculating probability, so you need the magnitude of this. Okay, so this is actually 2 by 3 plus 1 by 3 I now. What is the magnitude of A plus B I the whole square? The magnitude of A plus B I, that's under root of A square plus B square. So this is under root of A square plus B square. That's the magnitude, correct? So this is, and let's say root x square gets cancelled, by the way. I'm just calculating the magnitude, the mod of this. Mod means magnitude. I hope you have written, tell me if not. I've split it 1 by 3 I plus 2 I, 2 by 3. 1 by 3 I plus 2 by 3. So written 2 by 3 and 1 by 3 I. This is real value, this is scalar value. For any complex number z of A plus B I, the magnitude is what under root of B square plus B square. This is a very good application again. Students might just be stuck here, you know. They may not know what to do after this. You just have to take magnitude, simple. So magnitude is under root of A square plus B square, but then there is a square outside. So your answer is just A square plus B square. Okay. So this is just 2 by 3 square plus 1 by 3 square. So your answer is 4 by 9 plus 1 by 9. Probability is 5.9. A very beautiful question. Available exactly. I can bet on that it's a solved probability. If the guy has not explained any of the steps with such a detail. Okay. But I hope this helps. Please do all the 3 problems once again. Okay. That would be good.
Yes.
So we can stop here, and you believe we'll meet tomorrow in the evening and we'll continue with the chapter. Thank you so much. Thank you.
Thank you, sir.
No problem.
Thank you, sir.
No problem.
Thank you, sir.
No problem.
सर
बोलो।
सर अगर क्वेश्चन में दिया है कि ऑर्थोनॉर्मल है और नहीं दिया है कि नॉर्मलाइज है, तो क्या हम मतलब नॉर्मली चेक करना पड़ेगा या ऑर्थोनॉर्मल दिया है मतलब वो नॉर्मलाइज भी होगा?
नहीं ऑर्थोनॉर्मल का मतलब है कि like this thing is valid, c1 square upon c1 square plus c2 square plus c3 square. So this will be a probability. This is the meaning of orthonormal. But when you will get this in the denominator, only when c1 multiplies, no? Only when c2 multiplies.
Yes, sir.
So this denominator we get denominator. We get this denominator when orthonormal. And if it is not orthonormal, in that case we will get such a bhalka wala result.
Like c1 c2 c2 c3
c1 c3 multiple times. Okay, so we get all those also. Okay, so this does not necessarily mean, right, that it will be normalized. Normalized means that the sum of square of all should be 1. So if this is 1, then it is normal.
ओके सर, मतलब वो स्पेसिफिक दिया होगा, नहीं तो हमें चेक करना पड़ेगा।
हाँ, otherwise we have to check.
ओके सर, ओके, थैंक यू सर,
No problem. Shall I end the session?